Okay, welcome students to the Chapter 2 test common errors. Okay, first we'll start with this question here, finding the perimeter of this object. So the definition of the perimeter is basically the lengths around the object. So my highlighter here is outlining the perimeter of this object. Okay, all we've been given as information is the area of n and the area of m, and we know that they're both squares. Okay, so first thing we know is that the area of a square is its side times itself. So I'll make little m. So the area 32 is equal to little m squared, which would be the side length of m here. Okay, so to find the actual length of m, we're going to take the square root of each side. So we square root each side to solve for m. And we get the square root of 32 equals m. So this would be in centimeters. We'll deal with the units at the end. Okay, so this is m. This actually can be simplified, square root of 32. We can simplify that because 32 has a factor that's a perfect square. And the largest of that is 16. So I can write this as 16 times 2 equals m. And the square root of 16 is 4. So this is the side length of m. Okay, so now I know that side, I know that side, I know that side, and I know the same over here. Notice that there are 6 of them. 1, 2, 3, 4, 5, 6. So the total outside would be 6 times this value over here. We'll get to that a little later. All right, now m. I need to find the side length of m right here. So we'll do the same thing for m. For n, sorry. So we have 80 equals to n squared. Again, little m will be the length of this square, and I have already stated this side length here. And we solve this the exact same way. Square root of both. We're left with square root of 80 equals to n. Again, we can simplify this radical because it has a factor. 80 has a factor that is a perfect square. In this case, it's 16 again. It's 16 times 5 gives you 80. And square root of 16 is 4, so this 4 square root of 5 equals n. Okay, so I figured this out. I figured those three. I figured those three. I figured out this length. I figured out that length because that's also n. All I'm left with is those two little pieces. Okay, well, if you look closely, this length right here is just the subtraction of large n, right, minus n. So n minus m gives us this little piece. So let's call this little piece x here. And notice that it repeats twice. So x would be equal to 4 square root of 5 minus 4 square root of 2. Okay, so I have all the pieces I need to find the perimeter. Okay, so how many m's do we have? We have 6 m's. So the perimeter is going to be equal to 6 times m, which is 4 square root of 2. Okay, again, m, 1, 2, 3, 4, 5, 6, plus 2 times n. So 2 times n, because we have an n here and n here. So 2 times n, which is 4 square root of 5. And then we have these two lengths here, which is defined by this, and we have 2 of them. So we're going to have plus 2 times 4 square root of 5 minus 4 square root of 2. Okay, and all we have left to is simplify. So this simplifies to 24 square root of 2. So don't forget, when you multiply radicals, you multiply the coefficients together and anything inside the radical together. So in this case, it would be 24 square root of 2. In this case, we'd have 8 square root of 5. And here, using distribution property, right, this 2 multiplies into both. So we'd have plus 8 square root of 5 minus 8 square root of 2. And the last thing we got to do, we're going to simplify this here, common terms. We have 24 square root of 2 minus 8 square root of 2. That comes out to being 16 square root of 2. And now we have 2 of these, which come out to being 16 square root of 5. And there's your perimeter. Alright, on this page, the first equation is the radical equations. We have radicals inside of an equation. Anytime you want to get rid of a radical, which is what you're going to need to do to solve for x, you're going to have to square. And when you square something, you're squaring the side. So this whole side is squared, and this whole side is squared. Well, what happens when you have square of a square root? Well, it goes away, right? Again, this is the property of, this is to the power of a half, to the power of 2. Those cancel out to the power of 1. So what we're left with is 5x plus 3 equals to 3x plus 1. And at that point, this question should be pretty easy. We're just regrouping the x's to the same side, and we'll put the constants to the same side as well. So I'm going to subtract 3x on both sides, and you're going to have 2x left over here. And I'm going to subtract 3 on both sides. You're going to be left with negative 2 over here. So our solution is x equals negative 1. Okay, that's all great. We have x equals negative 1, but you always have to check this solution. So you should always verify that this solution is correct. So let's put it back into our original function. So this is a verification. I'll put a v here to represent that. On the left-hand side, okay, so I'll put a left-hand side here. On the left-hand side, you have square root of, if you put in negative 1 here, you have 5 times negative 1 plus 3. And if you look carefully, this is going to give us the square root of negative 2, right? If you plug that in. Okay, well, that's a problem, because we cannot take the square root of a negative number. Therefore, this is what we call an extraneous root. It means the solution, the way we've solved it, gives us this answer. But if you go back to the original equation, it doesn't work. So what you got to do is you need to eliminate this, and therefore, there is no solution to this problem. Okay, the next side. Okay, well, we're going to do the same thing. Notice that the square roots here of x, square root of x, they share the same square root. And for example, if I had 2 square root of 2 plus 3 square root of 2, like the last page, similar, you can add the 2 together because we call those common terms. They share the same root. Well, these two share the same root. So what I can do is, on each side, I'm going to subtract 6 square root of x on that side, and subtract 6 square root of x on that side. Okay, so what do we have left? So we have 4 left on this side. On this side, we have 7 square root of x minus 6 square root of x, which is left with 1 square root of x. And we have a plus 1. Notice that the 4 and the 1 are not part of the square root. The square root does not extend over. Here it extends over, here it does not. Okay, so now I'm going to move this 1 over to the other side. So subtract 1 on each side. And again, same thing. Whenever I need to get rid of the square root, I need to square each side. So if I square this side, I square that side, notice what's going to happen for the square and the square root. It's going to cancel itself out, and you're left with 9 equals to x. Okay, so don't forget, always verify your solution to make sure that your solution is correct. You plug in your 9, so from the left-hand side, we plug in the 9, we have 6 square root of 9 plus 4. And square root of 9 is 3. So 3 times 6 is 18, plus 4 is 22. And now on your right-hand side, plug in 9. So 7 square root of 9 plus 1. 7 times 3 plus 1. So 21 plus 1 is 22, which verifies our solution. All right, hopefully that helps you out, guys.